All right, welcome. We're talking about multiplying polynomials. Remember, adding polynomials, when we were adding, subtracting, we needed some sort of like term. So you could add an x squared and get a 2x squared, where if you had an x to the 3 plus a 2x to the second power, you would have to kind of leave that as is. With multiplying polynomials, your exponential rule that you want to consider, if you have x to the n times x to the m, that ends up actually being x to the n plus m. So you're actually adding the exponents. Here, you weren't adding any exponents, you were just looking for like terms. So if I had x to the third times x squared, that's x 3 plus 2 x to the fifth. So that when you end up multiplying, let's say, a mono times a poly, and a lot of times it'll be presented to you with parentheses. Let's say you have 3x squared times x to the third, and let's call this 4x. Let's just call that 4x. This is how you'll be presented with multiplying polynomials. The first thing to consider is using the distributive property. So everything on the outside of this parentheses is going to be multiplied to everything on the inside. And you would end up with a 3x to the fifth, because I did that 2 plus 3 there, and basically multiplying 3 times 1, plus 12, because I did the 3 times the 4, x to the third, because I did 2 and the 1, 2 plus 1. And that's how I'd multiply a mono versus a poly. Now you do have other cases where we had kind of poly times poly, let's say, and in this case, these polynomials are known as binomials. So maybe you had x plus 3. Maybe we look at it like this. And that was when we were using a bit of our FOIL method to help us organize our x to the third, our distribution property, x, this is really x to the 1 here, plus 3x squared. And then let's look at foiling this here, in which we got x squared plus the 3x, keeping in mind that we did have like terms here, so there is going to be a bit of going back to adding and subtracting of polynomials based on what we see as far as like terms take us. Now you end up with something pretty extensive, like you have a binomial times a trinomial, both of which are polynomials. And one way, there's two methods to this. One way I like to do it is kind of look at, I take this term here, this x, and I say x times everything. So I kind of break it up. It is almost like another FOIL, but I end up with x plus 3x minus x squared. Actually, this should be 3x squared, and this should have been adding the exponents, x to the third. And then I'll take this negative 2. That's an ugly negative 2. I'll take this negative 2 and multiply it to everything inside here. And what I like to do is stack. I like to stack my like terms, let's say. So if I get negative 2 times 1, I see that at this top level here, there's no integer here, if I'm looking here. So maybe I'll just add a 0 so I could put a negative 2 underneath that. This way I'm creating columns so I could keep track of my like terms. Now the negative 2 plus the 3 plus the 3x gives me a negative 6x. So where does that match up? That matches up here with my other x to the first exponent. And then I have 2 times the negative x squared, which ends up being a positive 2x squared. I don't have an x to the third, so maybe I'll use this as basically like a placeholder. And then I could work down and say negative 5x plus 5x squared minus the x to the 3 minus the 2. And then I could work towards standard form here, and then, you know, go from highest degree to lowest degree. And kind of list my variables like this. I think this stacking is a great way to do it. You can, you know, kind of take this and multiply everything to this, and then kind of list it as a bunch of values, and then try to find your like terms. You know, basically doing like this x plus 3x squared minus x to the 3 minus 6x plus the 2x squared minus the 2. You can list it like this and then try to look for your like terms, but I kind of like stacking it to show my like terms. There is another method where you can take this question and kind of look at it like this, 3x plus 1, and you have the x minus 2. There is this method here, which is basically kind of like my method, and you would almost like if you were doing like 102 times 32, you multiply the 2 times 4, the 0 and the 2, and then you have the 6, the 0 and the 3. Almost you do the same thing, and you end up kind of stacking it the same way, where you end up with negative 2 plus 2 plus the, let's say, 6x plus the 2x, and then they kind of stack it like that. But I really think that this is your best, most organized way of multiplying this. And the next thing we're going to look at going from here in a separate lesson is what happens in what they call binomial expansion, meaning when I have something such as this and I'm multiplying a binomial by a binomial by a binomial, and then what we'll start to look at is Pascal's triangle. But that's a whole separate video, whole separate pattern, but really cool piece of math is Pascal's triangle. So that's multiplying polynomials in a nutshell. Obviously, practicing a bunch of examples is going to help you with this. But the key piece is this exponent rule, where you're adding the exponents, and that's kind of your key piece when multiplying polynomials. And even if you had like a x squared y plus 3 times, let's say, an x y plus 4, and if you were multiplying this first term here, you know, you're ending up with an x3 y2 because I've added these exponents. So that's another little, if they're giving you multiple variables, another little piece there that could help you going forward just by adding your exponents.